Hello friends, welcome back. Let's discuss the next 5 questions from the NLP interview readiness learning process. We explain the concept of attention mechanism in NLP models. Attention mechanism in NLP models allows the model to focus on relevant parts of the input sequence when making predictions. Yes, the focus is important, and that's true on the relevant parts of the input sequence is very important, and that's what attention mechanism brings you. It will assign different weights to different parts of the input, improving the model's ability to handle long sequences and capture dependencies between the words more effectively. I'll give a simple example. Let's take mission translation. Attention mechanisms enable the model to align the source words with target words by assigning higher attention words to relevant words in the source language during translation. This way, we get better results. What is the difference between bag of words and word embeddings? BOW, bag of words, represent text as a sparse vector where each dimension corresponds to a word and its values indicates the frequency. Each dimension corresponds to a word and its value indicates frequency. Word embeddings on the other side, like word to work or glove, represent words as dense vectors in the continuous vector space, capturing semantic meanings and relationships between the words and their context. Let's take an example. In the BOW, if you assume the sentence, the cat jumped over the fence, could be represented as 11011, corresponding to the words cat jumped over fence. But in word embeddings, similar words for cat and the kitten have vectors very close together in the embedding space. So that's a major difference that you can understand. Explain the concept of sequence to sequence models in NLP. Sequence to sequence models are neural networks used for tasks where input and output are both sequences of arbitrary lengths, such as machine translation or text summarization. They typically consist of an encoder network to process the input sequence and a decoder network to generate output sequence. There must be encoder, there must be decoder, encoder for input, decoder for output. That's it. We'll take an example. In the machine translation, encoder-decoder sequence-to-sequence model would encode a source sentence in one language and it can decode the target sentence in another language. So this is the way encoder and decoder will work with sequence-to-sequence models in NLP. How do you handle the text pre-processing tasks such as lowercasing, punctuation removal, and stop word removal? We have a lot of libraries available in Python. The most famous are NLTK and SpaceI. You can use NLTK libraries functions and SpaceI libraries functions for you to remove or do all this kind of stop word removals or punctuation removals or lowercasing kind of activities. It's going to be very simple and easy to do, and you can try it out. We have given some examples as well in the other videos. What are the evaluation metrics used for text summarization? The most common and the most famous evaluation metric is ROE, recall oriented understudy for gisting evaluation, which measures overlap of n-grams between generated summary and reference summaries. The next one is BLEU, bilingual evaluation understudy. It compares n-gram overlaps similar to machine translation. And there is another metric finally, METEOR, metric for evaluation of translation with explicit ordering, and it considers synonyms and word order. Thank you very much. We will meet with next set of questions shortly.